humanoid robot is a robot resembling the human body in shape. The design may be for functional purposes, such as interacting with human tools and environments, for experimental purposes such as the study of bipedal locomotion, or for other purposes. In general, humanoid robots have a torso, a head, 2 arms, and 2 legs. Though some humanoid robots may replicate only part of the body. For example, from the waist up, some humanoid robots also have heads designed to replicate human facial features such as eyes, mouth. Androids are humanoid robots built to aesthetically resemble human. For a sensor is a device that measures some attribute of the world, being one of the 3 primitives of robotics, besides planning and control. Sensing plays an important role in robotic paradigm. Sensors can be classified according to the physical process with which they work, or according to the type of measurement information that they give as output. In this case, the second approach was used. For the second one is proprioceptive. Proprioceptive sensors can sense the position, orientation, and speed of the humanoid's body and joints, along with other internal values in human beings. The otoliths and semicircular canals in the inner ear are used to maintain balance and orientation. Additionally, humans use their own proprioceptive sensors for touch, muscle extension, line position to help with their orientation. Humanoid robots use accelerometers to measure the acceleration, from which velocity can be calculated by integration. Tilt sensors to measure inclination. Force sensors placed in robots' hands and feet to measure contact force with environment position. Sensors that indicate the actual position of the robot, from which the velocity can be calculated by derivation, and even speed sensors. For the next one is exteroceptive, an artificial hand holding a light bulb. Arrays of factors can be used to provide data on what has been touched. The shadow hand uses an array of 34 tactiles arranged beneath its polyurethane skin on their fingertips. Tactile sensors also provide information about forces and torques transfer between the robot and other objects. Vision refers to processing data from any modality which uses the electromagnetic spectrum to produce an image. In humanoid robots, it is used to recognize objects and determine their properties. Vision sensors work more similarly to the eyes of human beings. Most humanoid robots use CCD cameras as vision sensors. Sound sensors allow humanoid robots to hear speech and environmental sounds. Skin to the ears of the human beings, microphones are usually used for the robots to convey speech. The actuators are the motors responsible for motion in the robot. Humanoid robots are constructed in such a way that they might the human body. They use actuators that perform like muscles and joints, though with a different structure. The actuators of humanoid robots can be either electric, pneumatic, or hydraulic. It is ideal for these actuators to have high power, low mass, and small dimensions. For the electric actuators are the most popular types of actuators in humanoid robots. These actuators are smaller in size, and a single electric actuator may not produce enough power for a human-sized joint. Therefore, it is common to use multiple electric actuators for a single joint in a humanoid robot. An example of a humanoid robot using electric actuators is HRP2. For the hydraulic actuators produce higher power than electric actuators and pneumatic actuators, and they have an ability to control the torque they produce better than other types of actuators. However, they can become very bulky in size. One solution to counter the size issue is electrohydrostatic actuators, EHA. The most popular example of a humanoid robot using hydraulic actuators in the Atlas robot made by Boston Dynamics. For the last one is pneumatic actuators operate on the basis of gas compressibility. As they are inflated, they expand along the axis, and as they deflate, they contract. If one end is fixed, the other will move in a linear trajectory. A popular example of a pneumatic actuators is the McKibben muscle.
So, figure 1 shows a block diagram depicting a human arm has a force augmenting device FAD interaction where two controllers work in parallel. One consists in the central nervous system of a human and another operates the actuator of the FAD. The human operator generates the desired trajectory and exit torque that permits the FAD to follow the desired trajectories closely. The electronics in the exoskeleton measures the human interaction with sensor and provide low mechanical impedance in the human desired trajectory with the help of actuators. The block central nervous system CNS, reflex muscle and endoskeleton represent the dynamic associated with the human arm movement. The CNS performs the coordinate transformation, the trajectory planning and the motor command generation. Hence, the CNS generates the desired trajectory and pass the information to the spinal cord. A closed loop feedback control is executed by the reflex in the spinal cord in order to move the arm whose trajectory mimics the desired human arm trajectory as closely as possible. Next, the measurement controller principle and control elements for humanoid robotic is for measurement is humanoid robots use accelerometers to measure the acceleration from which velocity can be calculated by integration. Sensor to measure inclination. Force sensor placed in robot's hands and feet to measure contact force with environment. Position sensors that indicate the actual position of the robot. So next, the principle is this paper presents a contribution to the study of control law structures and to the selection of relevant sensory information for humanoid robot in situation where dynamic balance is jeopardized. In the example, consider the system first experience large disturbance and then by an appropriate control action resumes a normal posture of standing on one leg. In order to examine the control laws used by humans, an experiment was performed in which a human subject was subjected to perturbation and the ensuing reaction were recorded to obtain complete information about the subject motion and ground reaction force. Then a humanoid model was advanced with characteristic matching those of the experimental human subject. The whole experiment was simulated so as to achieve a simulate motion that was similar to that of the human test subject. The analysis of the control laws applied and the behavior of selected ground reference point ZMP, CMP and CM projection on the ground surface provide valuable insight into a balance strategies that humanoid robot might employ to better mimic the kinetics and kinematics of human compensating for balance disturbance.
And the next one is diagram with proper labels of humanoid robotics. As you can see, this is the humanoid robotic, and we got inertial sensor in the head, microphones, cameras, right arm sensor, left arm sensor, tactile system, there is fingertips and palm, right leg sensor, left leg sensor, and angular encoder at all joints. Next is advantages and disadvantages. First of advantage is it is a robot with its overall appearance based on that of the human body. It consists of the torso with a head and 2 arms and 2 legs. Although some forms of humanoid robots may model only part of the body. For example, from the waist up, they may also have a face with eyes and a mouth. Androids are the humanoid robots built to resemble the male humans, and Genoid are the humanoid robots built to resemble the human female. Second advantage is it has a head designed to replicate the human facial features like the eyes and mouth. It can be used for the functional purpose like interacting with the humans, tools and the environments. For the experimental purpose such as the study of locomotion or for other purpose. The third one of the advantages is humanoid robots can perform any task a human being can, so long as they have the proper software. Although they look realistic, they have no cognition or physical autonomy. They can be used for future dangerous and distant space exploration missions. They can serve as the companions or assistant for humans in daily life. They can be used as ultimate helper in man-made and natural disaster. And for the disadvantage, humanoid robot is very expensive depending on how advanced the robot is. As the humanoid robot starts becoming more and more available to society, it will be mostly the wealthy who will be able to afford them. It will replace the jobs, although this will be beneficial to many companies. It will hurt those who have jobs in certain fields such as nurses, pharmacists, secretaries, and another. Second one is the advanced humanoid robots will be able to complete a variety of tasks, but they cost a lot of money. For middle class or low income families, it is a high expense that many people can afford. The price of humanoid robots are high enough that everyone can own one. One of the common problems taken in the human robotics is the understanding of the human-like information processing and the underlying mechanism of the human brain in dealing with the real world. And the last one of the disadvantage is a lot of people will suffer from the humanoid robot. Humanoid robot will replace their jobs. Middle class and low income families will be affected by the robots. Although much of the upper class will be able to have these humanoid robots to do certain tasks that they don't want to do. Middle class family will not be able to afford them, meaning that they are stuck doing the boring tasks themselves. And that's it from me.
For summary, humanoid robots are used as research tool in several scientific areas. Researchers study the human body structures and behavior biomechanics to build humanoid robots. On the other side, the attempts to stimulate the human body leads to a better understanding of it. Human cognition is a field of study which focus on how humans learn from sensory information in order to acquire perceptual and motor skills. This knowledge is used to develop computational model of human behavior, and it's been improving over time. It has been suggested that very advanced robotics will facilitate an enrichment of ordinary humans. So dari video tu kita dapat nampak yang perkembangan robot di mata dunia ni semakin tinggi. So yang tadi tu adalah contoh robot yang bernama Amnika. Itu adalah dia macam robot yang membentuk manusia dengan menggunakan full structure of human. Jadi pergerakan dia daripada segi pergerakan dia memang akan nampak seperti manusia, bukan saja daripada segi struktur dia, tapi skin dia pun bergerak seperti manusia juga. Jadi kita boleh Amnika ni dia diambil macam daripada robot-robot yang sebelum ni untuk dia improvekan lagi robot-robot sebelum ni. Jadi untuk maklumat lanjut boleh tekan link dekat YouTube tu. Sekian, terima kasih.